Hello guys, welcome to the channel. We are learning object-oriented programming and this is the third video in the OOPS module. In the previous video, we did a practical implementation of creating classes and methods and attaching some attributes to them. In this video, we are going to focus on class methods and static methods. And towards the end of the video, I've also added a bonus section where we will discuss a little bit about datetime library and also some magic methods. Magic methods is something I was planning to cover much later, but in this video, I've just added a glimpse of it. And if you're new to this channel, this module is a part of my hands-on Python for beginners playlist. So if you're someone who's just starting out on your Python journey and if you're looking to cover Python right from the very basics up till a point where you will be able to make industry relevant projects, this playlist might be for you. And the link for the playlist will be in the description as well as in the I button on the top right corner of your screen. With that being said, let us quickly jump into the video and learn about class methods and static methods. So guys, today's video is going to be all about class methods and static methods. But before that, let us do a quick recap of everything that we have covered in the previous class. So I'm here at the agenda that I had set in the previous video. So far we have covered creating a simple class. So we looked at syntax and structure of a class in Python. So we are using the keyword class and then we are giving the name of the class and then we are using the init or a constructor, init method or a constructor to initialize some data into the class at the time of the instantiation of the class. So when we are creating the class, we want to attach some data to it. We are using a special magic method which is called as init, and this is a dunder method, which means there are two underscores before and two underscores after. This is also called as a magic method, and we will look at some magic methods even later. And we also understood the meaning of self. So self actually represents the instance, right? I hope this is very clear. So we learned about the meaning of self and why all the methods that we were defining were taking self as the first parameter, because those were instance methods and self is representing the instance. Okay, and then we learned about creating instances and objects. How do we create an instance of a class? And we took some example. I think we took the example of a car class and that of a employee class. After that, we also looked at the different ways of accessing the methods. One was using instance, which was a more common method, and then using the class. So I hope you are able to recall all of this. If not, please go and watch that video again. I'll link it somewhere in the description. And then we also talked about accessing the namespace of different instances and classes. So that we were doing using dunder dict. Okay, this is again a magic method or a dunder method, and method resolution order is something we have not seen, so we will see this along with inheritance. Moving to the next topic, we talked about adding variables or attributes and methods to the class. So we talked about instance variables and defining methods. So when we talk about methods of a class, there are three different types of methods. So we have already seen one type of a method, which is a regular method. Okay, the other two types are class method and static method. Okay, this is 1, this is 2, and this is 3. There are three types of methods. So we have already covered regular method. These are also called as instance method. Now why these are called instance method? Because they are taking self as a parameter, where self represents the instance. So today's video is going to be all about class method and static method. So as far as methods are concerned, I want to talk about one more special category of methods, for which we will use property. So this is called as a property decorator. So if we get a good grasp of regular methods, class methods, static methods, and at the rate property decorators, then we will get a very good hold of working with methods, and we will be very comfortable in using classes and methods and creating objects. Okay, so with that being said, let us get started with class method and static methods. Okay, so let us start. Let me give the heading class methods. So I would like to continue with the example on which we were working earlier. So let me look for the example. So this was the example, and we'll also do a quick revision of class variable. So this was the example we were working with, and let me also take a few employees here. So we were working with Ramesh and Ghanshyam. Very well. So here we had defined this employee class and we added this init method and we added this method get email and give appraisal. So these are instance methods. I think I've already mentioned this. And these are also called as regular methods. So any method by default is an instance method. So instance method is a default method. It is a regular method. Now, if nothing else is mentioned, we have to assume that the method is an instance method. And the first parameter that is being passed to instance method is always self. So I might have forgotten to tell you that using the word self here is customary. It is just a convention. We can actually use any word here. Python by default will treat the first parameter as self or a pointer to the instance. So here I can also replace this with instance, and that is also going to work completely fine. And now we want to talk about class method. So if I want to create a method that will modify a class variable, so here organization name and appraisal percentage, these two are class variables. Okay, so I want to modify the organization name or appraisal percentage for the entire class. Now we already know how to modify a class variable, right? So I can come here and I can just do employee dot organization name. I'm accessing a class variable using the class. Okay, so this is going to work completely fine, Codevera. And I can also access the class variable using an instance. So I can also do Ramesh dot organization name. Okay, and this is also going to work fine, right? And we have discussed this in quite a little bit of detail about accessing the variables using the instance and using the class. But now I don't want to do this, but rather I want to have a method that will change a class variable. So I'm going to come here and I'm going to write a function again. I'm going to say set organization name, and here I want this method to make a change to the class. Okay, keep this in mind. Earlier the methods that we were describing were changing the attributes of the instance. Now we want this method to change the attribute or a variable for the class. So instead of passing self, the custom or the convention is to pass class. I don't want to pass the instance, I want to pass the class, and therefore I will use class. But I can't use class because class is a reserved word in Python. So the convention is to use the word CLS. Okay, so I'll pass the class and I will pass the organization name, and then I'll come here and I will set the organization name for the class. Organization name is equal to, and let me change it to, from Codevera, let me change it to TechVera. So this is the new organization name that I'm going to put here. So if I come here and now I want to call this method, and suppose if I'm calling that method using an instance, so Ramesh is an instance and I'm saying set organization name, and I'm passing sorry, here I should not be passing TechVera, I should be passing the organization name. So this, I should not be hard coding it, sorry. So I'll come here and I will say set organization name. Let me create the class again. I'll come and say set organization name as TechVera. Okay, so if I do this, what do you think is supposed to happen? Do you think we have changed the class variable here? Because I just told you that using this word self is customary. Okay, we can use any word. So for this method we have not provided any information to Python to treat this as a class method. So for now still this method is actually an instance method, and when we are running this statement, this set organization name is going to the Ramesh instance. Here CLS is not representing the class, it is representing the instance. So there is something we need to do, or there is some information we need to give to Python to inform Python that this method is a class method, it is not an instance method. Renaming self to CLS is not sufficient here because this does not provide any information. For Python, CLS is the instance as of now. Okay, and to prove that, let me run this code, and if I come here and then if I check the class variable, you will see that it has not changed. Organization name, you will see it is still Codevera, the the variable that we had set in the beginning. So what can we do here to inform Python to convert this to a class method? We are going to use a decorator. So we will use a decorator called class method. Now I have not taught you about decorators as of now, so don't worry about it. Just remember the syntax. We need to write at the rate class method on top of any method which we want to convert as a class method. So if we write this decorator, by the way, decorators are a way to add additional functionality to a function. So we'll look at decorators in a separate video in detail. It is not necessary for you to learn how a decorator works to be able to use it. Just use this syntax, just add at the rate class method. Once we add this, what happens is that Python will start treating this CLS as the class, and it will not treat that as the instance. So once we have done this, and if I run this now, and now if I do employee dot set organization name, and now I'm going to maybe change it to Google. Okay, so now if I do this, okay, and now if I come here and if I look at employee dot organization name, you will see that we have changed the organization name at the employee level. I can show you the namespace of the class. You can see now the organization name here is Google. Now here we accessed we accessed a class method using the class. Okay, here we were trying to access the class method using an instance. Both are okay, both are going to work, but this is the standard way of doing it. Standard way of doing it. This is the standard way of accessing a class method. I'll show you that even if we instead of using a class here, even if we use an instance, suppose if I do Ramesh dot set organization name, and if I do maybe meta, this will also work. Okay, this will also work. Maybe not in this case because Ramesh we have already modified. Let me create Ramesh and Ghanshyam one more time. Okay, and if I do this and if I come here and look at employee dot organization name, you will see it has been changed to meta. So we can use a class method on using the class. We can also use a class method using an instance. Both are acceptable. This is not a common way of doing it. Okay, so when you're accessing a class method, try to use the class itself. Okay, let me revise one more time everything that we have discussed. We have a class variable organization name and appraisal percentage, and we were using some methods. The methods were taking instance, that's why they were being called instance methods. Let me rename this instance to self. Okay, and then we created a method which is supposed to change a class variable. So in order to change a class variable, the method should accept the class. Okay, but it is customary in Python to accept instance by default. So in order to convert a normal method from instance method to a class method, we are adding this decorator here. Once we add this decorator, this method has become a class method now. Now anything that we pass to this, the first parameter will be a class, right? Again, this CLS is not needed. We can use any other word. Maybe we can use apple here. That is also completely fine. Okay, so we can come here and you will see all the code is working fine. But the convention is to use CLS, so let us adhere to that. So let us take one more example to understand class methods a little better. So we were modifying this organization name class variable. Let us see how we can change this appraisal percentage using a class method and using an instance method so that we can paint the difference between the class method and instance method. So I'm copying this again here and coming down. Let me take this Ramesh and Ghanshyam back here. So now what I want to do is I want to change the appraisal percentage. So again, if I run this code and I want to have, say for example, employee dot appraisal percentage, okay, that is 0.1. And if I look at Ramesh dot appraisal percentage, let me print this. Okay, and let me print uh, Ghanshyam dot appraisal percentage. Okay, so the appraisal percentage for Ramesh and Ghanshyam is 0.1, and the appraisal percentage for the class is also 0.1, which means if I create any new employees, say for example I want to create a new employee here. Suppose I want to create a new employee called Shyam, and here let me rename this to Shyam, and let us say that Shyam is in HR department and date of birth is 1991 and the salary is maybe 80%. Okay, so I've created 3 employees, and let me add the third appraisal percentage also here. Okay, so all of them are having 10%. Now I want to modify, I want to see how I can modify the appraisal percentage for everybody versus if I want to give a special appraisal percentage to a given employee. Okay, so here I'm going to write 2 methods. Let me say set appraisal percentage, and here I'm going to give class. So this is going to be a class method, and here I will put appraisal PCT percentage, and I'm going to set class appraisal percentage is equal to whatever appraisal percentage I'm adding here. Let me not use it set, let me say update. Okay, and I want this to be a class method, so again I'm going to use the class method decorator, and I've created a class method, right? So I'll come here, and now I want to update the appraisal percentage for everyone. So I can say employee dot appraisal percentage, and I'm going to give 0.5. Sorry, it should be update appraisal percentage 0.5. And now if I come here and if I look at appraisal percentage of everyone, sorry, I made a mistake here. This should be appraisal percent. So now if I come here and if I run this code again, you'll see appraisal percentage for everyone has become 0.5. Now I want to update the appraisal percentage of a single employee. Okay, I just want to update the appraisal percentage of a single employee. So can I come and do here Ramesh dot appraisal percent, or let me say update appraisal percentage, and if I want to make it 0.8, if I run this, what do you think will happen? If I run this, what do you think will happen? Now this update appraisal percentage is a class method. No matter whether I'm trying to access it using the class or using the instance, it is going to change the entire class. Okay, because this method is accepting class. So if I run this, I'm not updating the appraisal percentage just for Ramesh, I have updated it for everyone. This might be a little bit tricky, but if you are able to understand everything that I've shown earlier, this should make sense. Okay, I'm accessing a class method. I can access the class method using the instance or using the class or using the instance. It is going to make change in the entire class. So if I want to change the appraisal percentage only for Ramesh, I should write using a method. Then I should write a separate method. I can say maybe update appraisal percentage for employee. Okay, and here I can come and here I can say self and appraisal percentage, and here I can do come and say self dot appraisal percent is equal to appraisal percentage, appraisal PCT. Okay, so now this is a instance method. This is a instance method. So I want to update the appraisal percent for only one employee. Then instead of doing 0.8 here, I need to come here and I can say update. Let me run this instance again and come here, and you can see appraisal percentage of everyone is 0.1 because that is what we have set here. And I can come here and say employee update appraisal percentage. If I'm calling it on employee, I'm calling this method. Then 0.5. If I run this, it is going to become 0.5 for everyone. Very well. Now I want to update it only for one employee. So I can come here and I can say update appraisal percentage for employee. Now this is a instance method. This is a instance method. So this is going to make change only for the instance. So here if I come and do 0.8, and now if I run this, it will be 0.8 for Ramesh, and for remaining two it is going to be 0.5. You see. Okay, so this example I wanted to give you so that you understand what is the impact of making a change in the class versus making a change in the instance. If you make a change in the class, all the instances of the class will get affected, versus if you are using an instance method, you are only impacting that particular instance. So now when I ran this code, Ramesh dot update percent appraisal percentage for employee, which was an instance method, I have updated the appraisal percentage for Ramesh. So if I go and look at Ramesh's namespace now, you will see that now appraisal percent is a attribute only for Ramesh. Now if I again change the employee class, again make a change in the employee class, suppose I'm making it 0.9, I'm updating the appraisal percentage for the entire class. I'm running this, and now if I run this, what do you think is supposed to happen? What will happen? Ghanshyam and Shyam will become 0.9 and Ramesh will remain 0.8. That is what has happened. Why Ramesh has remained 0.8? Because Ramesh already has an instance variable in its namespace because we have already modified Ramesh. So for Ramesh's appraisal percentage, we are no longer dependent on the class variable. Again, the explanation for this I have given in the previous video. The reason I'm stressing on this is because this can cause a lot of confusion with respect to a class method and an instance method and the way we are accessing it. So class method also we are accessing using the class and the instance. The instance variable method is also being accessed using the class and the instance. So in all the situations, unless you are very very clear in your head what exactly we are changing, what is a class variable, what is the instance variable, and what is the namespace of the class and what is the namespace of the instance, it might cause a little bit of a confusion. So please go through this, please understand this, and be very very clear in your mind about what is what. So let me write some comments here so that when you're looking at this notes it will be very clear to you. Here I'm writing here we are using a instance method which will change only the instance Ramesh. Okay, and this is we are using a class method. So the class variable is being changed. Here also I'll write this is a instance method because self is being passed, and this is a class method. So let me add some notes for you in case when you're revising it will be helpful for you. So here I'm adding some notes for you in case if you're looking at this notebook and you want to do a quick revision. Okay, so class method is a method that gets the class as its first argument instead of an instance. By convention, that first argument is named CLS. It is declared with a at the rate class method decorator. And it is useful when the behavior concerns the class itself, not a particular instance. So we want to make the change to the entire class, not to a particular instance like Ramesh or Ghanshyam. Or when you want an alternative constructor or a factory that adapts to subclasses. Now this part we have not discussed. I'll show you. By the way, there are a lot of applications of class methods, but usually class methods are considered to be slightly advanced topic. So I'm not getting into all the different possibilities of a class method because when you start working with Python as a beginner or as an intermediate, you might not come across those applications, and I don't want to confuse or overwhelm you at this point with a lot of advanced things. So at this point, if you just understand class methods and a few of its applications, that is sufficient. Once you become a little bit proficient and when you come across code, I'm sure that you will be able to understand it on your own. So we'll take one more example of class method as a alternate constructor. So far we have seen this class method as a way to change class variables. We'll see how class methods can also act as alternate constructors or a factory that can create new classes. Okay, so this is very interesting. Let us look at this example. So I'll come here and I will write class methods as alternate constructors. So far you already know about constructor, which is init method. So what does init method do? It assigns some information to a instance at the time of the creation of the instance, right? So when we are creating this Ramesh here, or we are creating this Ghanshyam, the init method is assigning this information to Ramesh at the time of creation. So when we call this Ramesh is equal to employee, what happens here is in the init method it becomes like this: Ramesh dot name, and this and all the self becomes Ramesh, and here we are passing Ramesh. Okay, so this is what happens when we do a init method. When we do Ghanshyam, all of this becomes Ghanshyam. All of this becomes Ghanshyam like this, right? This is the job of the constructor method. Now we are going to see if there is an alternate way to construct this. So I'm going to explain this using an example. So here I'm actually fed up of the employee example now. So let me create a new class, a new example. So this time I want to create a student, and I want to create a basic structure for a student class, and then we will see how we can manufacture students if the data that has been given to us is in a different format. And we'll look at class methods as an alternate constructors, and we'll, for that example, we'll take string as an input. So if we have a string as an input, or if we have a like a CSV file or an Excel file as an input where we have all the details of the students, based on that, how we can automate, or how can we create a factory where students can be created. Or so here I'm going to create a basic structure of a student class, provide some basic information using which we can create some instances of this class student, and then we look at an example of how class methods can be alternate constructors. Imagine that I want to create classes of students, and I have data of maybe 50 or 100 students given to me in the form of a Excel or a CSV file, or maybe a string file, right? So normally what we'll do, we'll parse that data and then we will start creating the objects. But there can be a different way to do accomplish this task using class methods. So let us get started. I will quickly create some basic init function. Let me say, in order for us to have a student, I'll take self. So I'm taking self, and then I'm taking name of the student and city of the student. Okay, and let me also take date of birth of the student. Okay, and then I will assign it to the student, saying self dot name will be equal to name, and self dot city will be equal to city, and self dot dob will be equal to dob. Okay, and I want to add just some method. Just want to show details. I'm just adding a simple method, normal instance method, and I will return, or I will, maybe I'll just print. Let me return, and I'll return a f string saying name of the student, and I want to show the city. So it should not be name; it should be self dot name and self dot city and self dot dob. So I've created this, and now I want to create some objects or create some instances of this student. So let me create student one, and this will be student, and I'll pass the name. So I'll pass the name as Rohan. Let me make R as capital, and then I'll pass the city. Let city be Delhi, and date of birth be 1990 09, and maybe 07. Okay, so this is the student we have created, and let me create one more student just for example. So let me make it Mohan, and let me make it Kolkata, and this will be student 2. So I've created a basic class of student, and I've created two students here. So this is a way of creating the student. This is the init method, or this is the constructor here. But suppose data has been given to us in a different format. So suppose the data for the students or a student database has been given to us in this format. Okay, so this is a multi-line string, and I want to create now students, Amit Sharma, Delhi, and date of birth, Priya Mehta, Mumbai, and date of birth. Like this, I want to create 1, 2, 3, 4, and 5 students. So what would be the ideal way? How would you approach it? Let me say data set. Based on the information given, how are we going to create 5 different students based on this data? So let us break down the problem. Let us take just one as an example for now. So let me call it student string, and this is the data that has been given to us. In order to create a student object out of it, I will have to parse this data first. So I will have to take student string dot split, and I'll have to split it from a comma, because this is comma separated, and normally you get data in a comma separated format. So if I do this, I'm getting Amit Sharma, Delhi, and the date of birth. So here I can take out the name, and I can take out the city, and I can take out the date of birth, right? So I'll do it this way, and then I can create my student. So I can say student, and I can say name, city, and date of birth. Okay, so here this will be my student 3. And now if I look at my student 3 and I want to show detail, you can see I'm getting the data here. So I've created a instance of the class student using the data like this, but this is slightly cumbersome. So a class method will help us do all of this within a class method. So let us see an example of how this will happen. So I'm going to come here, and I've created this student. Now I'll come here and I will create a method. I'll say def, and I will say from string. And here I'm going to make this, I'm going to pass cls, and I'm going to pass student string, and I'm going to make this as a class method. So this will be a class method. So within this, what I want to do is to parse this student string and return an instance of the class from within the class. Let me show you how that will be done. So I'll take this part, and I'll come here and I'll put it here, and this should be student string. Fine, everything is fine. And I'm going to create a class which will be student, and I'm going to create name, city, and date of birth. Okay, and I'm going to return this. Now I don't want to return student because the class variable here is referring to the class actually. So student, instead of student, I'm just going to write cls. Okay, so let me run this, and now if I come here and if I call, see student, and I'm going to say from string, and I'm going to pass the student string. So if I do this, you see it is returning me an object of student. Let me call this student 4, and if I come here and if I look at student 4 dot show details, you see I'm able to create it. Instead of student string as this, let me take Priya Mehta, like this. Let me take, come here, and let me say student string is equal to this, and I will come here, and you can see I have now created a instance of the class using a string. And this is very common, you will see in other libraries also. For example, if you have learned about datetime library, when you learn about that library, you will have a method called as from string. Or when you are in many different libraries, when we are trying to create objects, there are methods which are starting from. For example, we want to make a class from a string, so we have defined a class variable that is taking the class, and that is taking the data which is used to init or which is used to construct it, and this class method is creating that class instance within the method, and it is returning that. So what it is returning, this is returning, say for example, alternately we had done it this way. Okay, instead of doing this outside, I am doing this within the method, and I am returning this instance. So this is actually returning the instance of the class. So this method is actually acting as a constructor, acting as an alternate constructor. So you want to create a student, we can create a student this way, right? When we have the name, we have the city, we have the date of birth. But if we have name, city, and date of birth in a given format, for example, it is coming to us in the form of an Excel file or a form of a string, so we can create that method within the class definition and use that as an alternate constructor. So let me extend this idea. Here we were trying to create the class from a string. So I was given the data in this format, and I took one row at a time. But what if we could convert this to a list, and I can add a method here to create classes from a list? Let me show you that with an example. So what I'm trying to get to is, suppose this is the data set that I have. So can I convert this to a list? Let me create this student data list. Okay, so I want to take this data set. Let me first remove this, and let me just take this data set and let me split it. Okay, and let me see what happens. If you can see, okay, no, this won't work. Let me split it using new line. Okay, so you see what I've done here. I have created this string to a list. So I've taken this string, and now I have created this entire string into a list. And in this list, the last entry is actually empty because here there is a new line. So if I had this here, this would have been perfect. But say for example, I have it here itself. So I'll also show you how we can raise an error there. So this is the list that we have. So I can call it student data list. So I'm going to call it student data list. And now I want to create classes from this list itself. Okay, so I'm going to come here, let me take this example here and come here, paste it, and I have created this alternate constructor where we are creating a class from a string. I want to create it from a list also, so let me call it from list. Again, I will take the class and I will take student data list. Okay, and I will run a loop inside this method. Let me see, class method. Okay, and I'm going to come here and let me put pass here and show this outside what I'm trying to do. So this is the data that I have, student data list. So I want to run a loop. I want to say for student data in student data list, I want to create a class. So I want to create student, and I want to say student data, or I can use the from string method that we have created, because student data is going to be string. So I'm going to say from string, and I'm going to say student data. Okay, and I'm going to call the method show details here on that object. So I'm going to say show detail here, and let me run this. Okay, so I'm getting an error here. So let me just write down try, because it is giving me an error for the last one. So let me just print student data list. Okay, I'm getting an error for this one, which I will handle it in a while. Let me just first run this. Okay, and I'm going to say accept exception as E. I'm going to print student data, for which I'm getting an error. I know I'm getting an error for the last one. I'm going to run this. Okay, so if I run this, I should be able to see detail, but okay, so show detail is not printing anything because I am returning here. I'm not printing anything. So let me also print this instead of return, let me make it print. In that case, it will work. Okay, so let me come here, and if you see, I've been able to create student instances from this list. If you want, I can come here and I can make a print here, print statement, student created. So whenever this init method will be called, we will get to know. Okay, and this init method is definitely called in the string method when we are doing this. Okay, so let me run this here, and you can see I'm creating a student Amit Sharma, Priya Mehta, Rajesh Kumar, Sneha Iyer, and Arjun Reddy here like this. But now instead of doing this outside, what I want is I just like here I was passing a string and I was able to manufacture a student. I also want to pass this list and manufacture the student. I hope you are very clear on what I'm trying to do here. So instead of doing this here, I'm going to come here and do this here within the class, and I'll have to definitely make some changes here. Instead of student, I'll make it CLS. For student data in student data list, I'm going to create class from string. It will take this method and it will not show detail. Let me just return it, and exception as E. What I can do here is I can check whether this student data dot split will have, I can do this here. Okay, student string, and what I can do here is let me take student data, and I can check here if length of student data is not equal to 3. In that case, I'm going to raise an exception. Okay, I'm going to raise an exception saying that student data provided invalid, student data provided for, and let me give that string also. So let me provide that string, student string. So I'm raising an exception if we are passing an invalid string. So when we come to this part, this last string, I should be able to raise some exception here, and I'm returning the class name, city of birth. And when we raise an exception from string here, we will get an exception, and when we get an exception, it will be shown to us here. So except exception as E, I can print student data, and I can also print there was some issue. So for that student, we will get there was some issue. I hope that is what the code will do. Let us now run it. We have written some alternate constructor here. This is also an alternate constructor, and we have done some basic exception handling. So I'm defining the class again, and then again I am creating the data set, and this time instead of doing this, I'm just going to say student. You see, this entire line of code will be just one line if everything goes well. I'm going to say from list. Instead of from string, I'm doing from list. I'll pass the entire list. So entire list this is going to be student data list, and let us see what happens. You can see student created. Why just one? For student data in student data list, return. Okay, we are returning here, but we should not return because the loop will end. So I don't want to return here, because if I return here, then the loop will end. So what I'll do is I'll create a list of students, list of student instances. Okay, I'll just keep appending to it. Student instances, I'll make it a list, and instead of returning, I'll make it list of student instances dot append. And you see, now we are doing some real life work here from everything that we have learned in oops. So we are creating a list of student instances, and we are doing exception handling, and end of the day we want to return the list. And this is where I'm also building up some intuition for where representation of an object is also going to come in handy, because now when we will look at this list of student instances, we'll just get the memory addresses, which are very ugly to look at. So we also need some representation of the student, which we have not done so far, and that is a magic method we'll see later. But for now, I hope what I'm trying to do is making some sense to you. I'm trying to add a little bit of complexity here, in order to be able to relate everything that we have learned theoretically to some kind of a real life problem that you will be solving when you are on the job. Okay, so here I have created from list, and I have done some exception handling. I have created list of student instances. So it will take this list, it will create this instance for that student, add it to a list. Okay, and if there is an issue, for example, if the string is not proper, it will raise an exception and it will print the student data, and it is going to return the list of student instance for me. Okay, let me run this and run this. Okay, and let me run this now, and you see it says student created 1 2 3 4 5, and in the sixth one there was some issue because there is this empty string here, and we have gotten a list here of 5 students, right? So now if we look at this list, let me receive it with list of students here, and if I come and look at the list of students, you will see this is having 5 students, 1 2 3 4 5. Who are these 5 students? It's Amit, Priya, Rajesh, Sneha, and Arjun. But if I want to verify, because these are actually instances, they are just not represented properly. So if I come here and if I do list of students, and if I look at the last one, this will give me the instance of the student for Arjun Reddy. Okay, and if I go here and if I look at dot name, you see, sorry, Amit Sharma -1. If I do -2, this is still list of students. So actually I made a mistake here. I changed the variable here to student data. I was having name, city, and DOB, which I changed here, and then I forgot to change here. So what I can do here is student data is fine. Let me take out name. Let me do a tuple unpacking, name, city, and DOB. Unpack that student data because this is going to contain the name, city, and DOB after splitting it, and then I will get the name, city, and DOB here. And now if I run it, so I was getting some error. I was trying to debug it. You can see student created, and now I'm getting list of students, which is 1 2 3 4 1 2 3 4 5 students. And now if I try to check the name of the 0th student, it is Amit Sharma. If I check for the first student, it is Priya Mehta. Otherwise it is Rajesh Kumar, and the last student should be Arjun, I think Arjun Reddy. Okay, Arjun Reddy. Okay, so what we have done here, we have created a class student, and we wrote one constructor here that we will use normally when we have the name, city, and date of birth. But if we don't have name, city, and date of birth in a convenient format, if we have it in the form of a string, then we have written a class method that will take the string, parse it by splitting it, and then do tuple unpacking, do some basic exception checking or quality checking, and then it will create the instance of the class using this normal constructor. So this is the normal constructor that is being used, and it is returning the instance of that class which got created. So we have found out a way to create instance of a class from a string, basically. Okay, that is the summary of the entire story. And then we took things one step forward, saying that if we don't have a string, say for example we have a list of students, we got a list of students, maybe the data is stored in a database, we made an API call to the database, and we got all the data in a table format. We were able to parse that table into a Python list. So now we have the Python list. Is there a way I can pass the entire Python list and get all the students? Suppose we had a list of 100 students. Can, instead of doing it one by one, can I just write that logic within the class itself, and in the end whoever is using my software, he will just enter the list, he will just throw the list, and class will take care of parsing the list and creating the students, and it will return the students. So that is what we did here. If we got a data set here with list of students and their details in the format, and there can be some mistakes also, so those mistakes we can check here. I did a basic check of whether there are 3 components or not, because we want 3 components in order to create the student. And then we parsed it, and then we created a method like this. We said student from list, and we were able to do student data list here. So this is how class methods are used as an alternate constructor. Classes are also used, this is also an application where we can say that we are creating a factory where we are passing the data, and it is manufacturing students based on the raw material that we have given to the class. That's a very layman way of talking about how class methods act as alternate constructors. And so these were the examples, and this is all that I wanted to discuss as class methods. If the last part is not very clear to you, don't worry about it. Just keep in mind what class methods do, and that should be completely sufficient for you to be able to work with OOPs and classes and objects in Python, at least in a beginner and an intermediate level. So now next topic that I want to talk about is the third category of methods, which was static methods. So we started with regular methods, and then we learned about instance methods, and now we want to talk about static methods. So what were instance methods? They took instance as a parameter and they modified the instance attributes mostly. Then we looked at class methods. They are taking class as an class as a parameter, and they are modifying class variables. Static methods are not related to class or instance at all. They neither take the class, they don't take the instance. So that makes a static method a normal function. We know methods are nothing but functions. So the only thing that makes a method special is that it is modifying the class or instance. That's why it is within the class, right? But static method is not doing any of that. Static method is just a normal function, but it is kept within the class because it is somewhere logically related to it. It can be outside the class also. It is just a normal function. So I'm going to show this to you using an example. I'll take the same student class and I'll come here and let me write here static method. So static methods, let me write, they don't take class or instance as a parameter. That's all. So they are like utility. You can say that they are like utility functions. So I'll give you an example. When we are creating this student class, we are taking date of birth. We are taking date of birth. Now, suppose we want to find out the age of the student. I want to find out age of the student. So how do we calculate the age of the student? Now calculating age is a completely separate logic. It has nothing to do with what class or what instances we are creating. Calculating age is agnostic of all of this. So I want to create a method that will calculate age. So how do we calculate age if we have date of birth? Say for example, if we have, let me write pass here and let me take a quick detour and show you how we calculate age. So for example, if this is the age, if this is the date of birth. So what is the logic for calculating age? Age will be equal to, if I want to calculate age in year, so it will be current year minus year of birth, right? If we are able to do this calculation, then we will be able to find out age. So age is current year minus year of birth. So how can we find current year? So for that, we'll use the datetime library. I think I've not shown you datetime library, but just bear with me. So I will do datetime. So datetime is the external library that helps us to manage all date and time related tasks within Python. So here I will do now. And these are all classes, by the way. These are all written using object-oriented programming. So this is giving me a datetime object. So this datetime is also a class. So if I convert this to str, you see it is giving me a string representation of this. And if I come here and if I say year, I hope that works. Okay. So this is giving me the current year. So this is my current year. So I have found out a way to find out current year. Now I want to find out year from this date of birth. So there are two ways to do that. One is that I can do dob dot split, and I can do it like this, and I can take the 0th element and I will get 1998. And if I'm able to subtract that current year minus dob, so this is year of, so this is not the advised way of doing it. I should be actually using a better method. I'll show that to you, but here is a jugaad method. So current year minus date of birth. So I'm getting a type error because both of these are actually strings. So if I can convert both of them to integer, then I should get, I think, 27 as an answer. Literal, this should be year of birth, sorry. Okay, so I should get 27 as an answer. So this is the age. So can we write a function? Can we put all of this logic? Can we put all of this logic inside this calculate age? So I can take this age logic here and let me return age. And how do we calculate current year? Current year is calculated using this. Fine. And year of birth is calculated using this. And I'm just subtracting both of them after parsing them to int. And then I'm returning the age. Now, if you look at this logic, this entire logic has nothing to do with self. It has nothing to do with class, right? I could have passed self here. Okay. I could have passed self here. And instead of dob, I could have made it self.dob. Okay. And then if I come here, then also this would have worked. But it is a personal choice whether you want to make it as a static method or you want to make it as a normal method. So if you're passing self or if you don't do anything to this, by default, this is an instance method. So even if I have dob here and if I remove this, this is still an instance method actually, because by default all methods are instance methods. In order to make a method as a class method, we were using this decorator. So here we need to come and add a decorator so that Python knows that we don't want this function to do anything with the class or the instance. So I can use static method. So if I use a decorator called static method, this is going to tell Python that whatever parameter I'm passing here, that is not supposed to be an instance. It is also not supposed to be a class. This is just a normal function. So DOB here, date of birth, will act as date of birth. If I remove this static method, then Python will think this as an instance method and it will treat DOB as an instance. Okay, so that's why it is very important to use static method here. So now I have created this, and let me now create some student data. I have the student data, I think, student data list. Okay, let me take the 0th element of this. Fine. And let me create a student. So I will say student from string using the alternate constructor, and I've created the student, and this is my, let me call him stud, and stud dot dob is 2001. And if I want to get the age for stud, so I can say stud dot get age, or sorry, calculate age, and this is the method. And I need to pass the date of birth here. So I need to pass date of birth here as this. So you can see I'm getting the age as 24. Now instead of doing calculate age here, what I can do is I can come to the constructor, and here I can add self dot age, so that I will be able to access it just like an attribute. And here I can do self dot get, calculate age, and here I can pass the date of birth of the person. Date of birth of the person is in self.dob. So this here is a static method. I'm calling calculate age. This is a static method. So if I come here, if you do calculate age, you have to pass the date of birth, which is not very cool. So I can do stud here, and now I can just say age 24. And if I create some other student, if I am taking this student, let me print stud dot name. Okay, so this is Priya Mehta, and the date of birth is 1999. If I come here, if I remove, there's no need for that. And if I calculate age, it is coming as 2026, 1999 to 2025. The age is 26. So this is the application for a static method. Static method, again, like I'm saying, it is a normal function. If you take this out of the class and if you keep it here, this looks like a normal function. This has nothing to do with the class or the method, but because this is being used in the student class to calculate the age of the students, that's why it is kept inside this class. It can be kept outside also, and if need be, this static method can be converted to an instance method also. I can also write this as an instance method. I can just remove this, and I can, instead of dob, I can pass self here, and here instead of dob, let me do self.dob. If I write it like this, if I comment this out, and if I write it like this is also going to work. Let me show you. I can come here. I don't have to pass dob here. Okay, so if I come here, if I run this, actually we don't have to pass it. Okay, calculate age, and you can see the whole thing works fine. Okay, so it is up to us to decide whether we want this to be a static method or for it to be a instance method. For now, I want it to be a static method, so I'll make this as a static method, and here I will come, and here I will pass self dot dob. Okay, so this is working fine. So because this is a static method, it is also eligible to be accessed outside directly using the class for general purpose use, because it is actually a utility function. So let me access it. I think I showed you an example, but I accessed using the instance, but ideally we should access it using the class. We can access using instance also, but that is not recommended. So we can do calculate. Let me run this. Okay, and I can do student dot calculate age, and I can come here and I can give any age, say for example 2004 and 08 and 09, and it will okay, it is saying date time not defined. So let me come here and we can say import date time, and you can see we are able to access this method directly using the class, and we can use this for a general purpose use. So we can also access this from the instance. However, that is not recommended, but I'll show you. So if I take stud and I can do calculate age, and we can pass the same value here, and we should be able to access it. So this is all about static methods, and this is all that I wanted to discuss in the video. In today's video, we talked about class methods, and we looked at a lot of examples, and we tried to tinker with the class variables along with class methods, and we also saw some alternate application of the class method as constructors, and then we looked at static method. Before we end the video, I just want to talk about two bonus things. I think when I was doing this calculate age function, I told you that this is a jugaad way of calculating year of birth if we have a date of birth. So actually we can use a datetime module for this. So let me just quickly show you that. And then I also mentioned at the time of creating this data set, when we were talking about alternate constructors, that when we do this list of students, we are getting this list of students, but they are represented in a very uh, ugly way, where we are getting the memory address of that student. We are not getting any representation. So we'll try to solve this problem also, and then we will conclude the video. So let me quickly show you how we could have written this function in a better way, especially calculating the year of birth from a date of birth. So we have date of birth in the form of a string. Let me take this as a date of birth, and I want to calculate year from this. So the earlier what we did was we split it based on this hyphen, and then we took the first element out of this. But suppose we wanted the month and the year also, and if suppose the timestamp was slightly complicated, so a proper way to do this would be to use datetime library. So we will use the datetime library. Again, I have not discussed about datetime library, but this should be fairly intuitive. So I'm using datetime dot datetime, and this has a method that takes a string and it will convert it to a datetime object. Now again, this is similar to what we did using class methods. We are creating a datetime object, we are inputting a string, and this function is kind of converting it to a datetime object. Okay, a instance of its own class. So here I'm going to give the dob, and I need to provide what is the format of dob, how it should parse. So it needs string and it needs format. So if you come to this method and if you press shift and tab, it will give you the doc string or little bit of information. So I can come here and I can pass the time also. So I need to provide the format. So there is a certain way in which we are supposed to provide the format. So we have year, and then we have the month, depending on whether you have YMD or YDM. I'm considering it to be YMD, and I will provide the date. So if we do this, you see it has given me a date time object here. This is very similar to how we got current date also. So if you want today's date, we can do datetime dot datetime, and we can do now. Okay, so this is like a datetime object, just like we created a student object or employee object. This is a datetime object. If you come here and if you do type on this, okay, this is a datetime object here. So we got this time here, and now what we want to do is we want to convert this to a year. So this will provide an attribute to me which is called as year. This is how the object oriented programming behind the datetime library might be working. So there's an attribute here called year. So if I do this, see, I'm getting a year here. And again, if I look at the type of this, it should be some datetime object, or it can be a string. See, it is actually returning me an integer. Fine. So I can convert any date of birth to a datetime object, and then I can extract year from it. I don't have to worry about parsing this from hyphen, although we can do that, but this is a more proper way. So I can come here and I can go to this calculate age function, and instead of doing this, I can come down and I can say year of birth is equal to this. Okay, and now if I do this student.calculate age, maybe I can just check this function separately, then you can put it in the dob. So this is the proper way to extract timestamp or a year from a string, a date time that has been provided to us. Okay. So another thing that I wanted to discuss with you was that when we were discussing this concept, where we had a data set and we wrote this from list constructor in the student class, and we ran a loop and we appended all those instances into a list. So we got a list here, but this list looks very ugly because the instances are added here, but there is no proper representation of these instances. They are actually giving us the default representation, which is the memory location. Now if you add an integer to a list, maybe 1, 2 and 3, and if you print it, okay, if I print it, see, it is printing it properly. It is giving me 1, 2 and 3. It is not giving me the memory location of where 1 and 2 and 3 are stored, because whoever has designed list, whoever has designed integer, they have also designed how they will be represented to the user. For example, list is represented using this brackets, and dictionary is represented using curly brackets. So for our student also, we should think of what to do when they have to be represented to the user, or for that matter, we should also think about what to do when we have to print it, or for example, a string representation of it. So if I do str of a list 1, 2, 3, you see it converts it to a string. But if I do a str of my stud, okay, it is not giving me anything that is meaningful. It is again giving me a string of this memory location where it is stored. So for this we need to add some design element in the class that will determine how our class will be represented. Suppose someone wants to print a student, what should be shown? Or if we want to represent it somewhere, what should be how should it be represented, right? And for that matter, if we do 1 plus 2, we are getting 3. So there is an operator. When we add plus between two things, what happens? If we add minus between two things, what happens? So these are topics of method overriding and operator overloading. We will see that later, but for now I just want to show you a couple of magic methods for printing and string representation of any object. Okay, so I'll quickly show that to you. Let me take this class and let me bring it down, and let me quickly show you two magic methods. One will be repr, which is representation, and one will be str, which is the string form of my object. Okay, so these two things I will quickly try to show you. So this is my student, and I don't have any method that tells me what should be a representation and what should be the string format. So let me make it this way, otherwise. Okay, so let me take one student here. Let me take this student. Okay, and I have this stud. Okay, so if I print this, if I add maybe one more student, stud 1 and stud 2. So we should think about what should happen when we are printing this stud. I don't want this, but what do I need? So suppose I want a string representation to have name of the student and a city of the student and the DOB of the student. Maybe I want it in this format. Suppose I want this to be the string representation of my class. So I can come here and I can say def. I can create str under str, and I can take self here, and I can return. See this. So I've created this string method here, and now if I come and if I do a print on my stud 1, okay, you see, instead of getting that memory location, I'm getting a very nice formatted string. So if I want to print a student, I'm getting the name of the student, the city, and the date of birth. Similarly, if I just write stud1 here, what happens? It is still giving me the memory location of this. And suppose if I want to create a list, okay, suppose I want to create a list of stud1 and stud2, still it is giving me like this. So I have not added any representation for these student instances of the student class, and that is what was happening here. If I come back and if you see here, see, this is what was happening. So what I want here is to have not have this memory location, but I want some representation. I want maybe name of the student to appear. So I'll come down here and I will add one more magic method, which will be repr, which is representation. So representation is usually for the programmer to see, and string method is usually for a string representation to the user. Suppose they print a student, or they print an employee, or they print a car, or instance of a car, instance of an employee. So what should be shown to them? So here also I want to change this, and I want to add a representation, but I will change this representation. I want it in a form of a say I want to say like this, student, and I want to have bracket, comma, and I want I want it to be in this format. I want it to be in this format. Okay, name, city, and DOB as a brackets. Okay, so this is my representation. So if I now again come, you see, if I'm printing it, it is going for the string method, whatever I've defined. But if I come here and if I just write stud1, see, I'm getting this representation now. This is what I defined here. This is what I have defined here. And if I now create a list, you see, I'm getting like this. So it is much more better to see what is happening here. So now if I come back and if I try to create this method now, if I try to run this code again, list of students is equal to student from list. If I take this and come back here, if I run this code, and now if I look at list of students, instead of getting the memory location, you see very nicely I am getting a reference. And now if I do list of students 0, this is actually instance of the class student. It is just being represented in a way that I have defined. So here if you come and if you do name, you see I'm getting Amit Sharma, and if you do a type on this, it is still an instance of the class student. So these are also these are called as magic methods. There are a lot of magic methods, but these two I just wanted to show you quickly because of the examples that I gave, these became a little relevant. So I thought I'll add it towards the end of the video. for representation. Okay, similarly I have not defined what happens when, suppose if I do stud1 plus stud2. Okay, you see it says unsupported operand for student and student. So if I do stud1 plus stud2, or suppose if I do stud1 greater than stud2, these are two students. So if I'm saying student 1 is greater than student 2, what does it even mean? Okay, I don't know what it means in the real life, but because I am the inventor, I am the god, I have created these students in Python. So it is up to me to decide what happens when someone is asking if student 1 is greater than student 2. What do you return? If I'm adding student 1 plus student 2, what should happen? So actually I can control it. Let me quickly give you an example. I can come here and I can add a magic method. I will discuss about magic methods in detail, but because we are on the subject, let me just quickly give you a teaser. So I will do add. Okay, and I'm going to add two instances of student. So one will be self, on which it is being called, and the other will be other student. Okay, other student. And what do I return? What should happen? Maybe I want to return their names combined. I want to, if the student 1 is Rohan and student 2 is Mohan, I want Rohan and Mohan to be combined. So I will say uh, I will return f string, and I will say Rohan, I will say self dot name. Just imagine, just something imaginary. I'll take some more relevant example later and I'll show you. And I will say other student dot name. Okay, I'm doing this. I'm just concatenating their names basically using a separator. So now if you see, if I come back here, if I create student 2, and now if I come here and if I do student 1 plus student 2, instead of saying type error because plus is not supported, now plus will be supported because we have added this magic method. This magic method is telling what should happen when two instances of these classes are added together. So so when they're added together, their names are going to be joined. That is the rule that I have created in this class. So if I come here and if I do this, you see it is Priya Mehta and Priya Mehta because I'm doing stud 1 and stud 2. What happened? uh, Other student dot name. Okay, stud 1 and stud 2 should, okay, they are both actually the same, that's why. Okay, so we'll come here and this time it is Priya Mehta and Rajesh Kumar. Why? Because stud 2 dot name was Rajesh Kumar. So these are some magic methods, and this is also operator overloading. I gave you one quick example, and we'll see more examples of this. But I hope this was pretty intuitive, and these are the two things I just wanted to add as a bonus in this video. This brings us to the end of this video, and let me just quickly revise what are the things we did today. Let me go back to the agenda. So of course, today we discussed class variables and instance variables, and we discussed in detail about class methods. Instance methods we already knew as the regular methods, and we discussed about static methods, how they are not taking any instance or any class. Class methods are changing the class variables. And we discussed a little bit about special methods also. We did not discuss about length. For example, if you have a dictionary, you use the function length function. So it tells you how many different elements are there in the dictionary or in the list. So suppose someone calls the len function on your class instance. If someone says length of student 1, what should happen? Of course, it does not make any sense, but if you want, you can define these things. And this is how they allow operator overloading. So I quickly showed you dunder add, and that is actually operator overloading. And in the next video, we'll talk about inheritance and polymorphism, and we will also take one video and we'll practice. So we have taken student class and car class and employee class. We will take more classes, we'll take some problem statements, and we'll try to implement everything that we have learned, and then we'll move to inheritance and polymorphism. And then we'll also talk about property decorator, right? And we will also talk about one more topic which I have not mentioned here, which is name mangling. Okay, that is also a very interesting topic. That is how we can make some variables as private variables. So I will figure out somewhere we will also discuss name mangling in Python, the concept of private variables. So if we do all of this, then we will be in a very good position, and we will be able to say that we know object oriented programming, and definitely we'll do some projects that will solidify our learning even more. So this was a little long video. I tried to cover a lot of things in this video, but I hope you are following the videos. And if you have any questions, if you have any doubts, please write them down in the comment section. I will definitely try to help you. And if you have anything else that you want to discuss with me, if you have any suggestions or if you have any other questions, you can also connect with me on Discord. The link is in the description below. And if you're new to the channel, this module is a part of my hands-on beginners playlist, where we are covering all the Python topics right from the very basics to a point where you will be able to make industry relevant projects. So if you're someone who's just starting out on your Python journey, please check out the playlist. I will link the playlist in the description. It will also be available on the screen somewhere on the I button probably. So thank you, and I will see you in the next video.